Hello, welcome to this AWS webinar. My name's Ian Massingham. I'm a technical evangelist with Amazon Web Services based in Europe. I'm going to be your host for this session. And today we're back on the journey through the cloud, which is our intermediate series of webinars. So these are intended for people that know a little bit about AWS, but want to learn more about which AWS services they can apply to a specific set of business challenges or a specific use case that they might have. And today we're focusing on scalable web apps. I'm going to be talking about that quite extensively during today's session. Before we get started with that, as usual, just a bit of housekeeping for you. So you can find the materials from today's webinar in the materials download section of the webinar interface, which you'll see labeled as the files panel. So if you want to grab a PDF of the presentation materials from today, please do that. The other thing that you'll see in the webinar interface is some links where you can find some links to AWS social media accounts and also links to some of the additional resources that you might be interested in following up to learn a little bit more about today's webinar topic. And while we're on the topic of social media, we'll also show you some social media accounts at the end of the session today that you can follow on Twitter if you want to stay up to date with AWS globally and also with AWS here in the UK and Ireland. Of course, you can stay up to date with future webinars that we're running if you do that as well. And lastly, there's one other webinar series that we're running called the Masterclass webinar series. You can see a link to a page with more information about that also in the links panel for the webinar. And that's a webinar series which is a deep dive really into specific AWS services. So we've already covered CloudFormation in detail so far this year, and we're going to have further masterclass webinars coming up throughout 2015. So if you want to dive deep into specific AWS services, you might also want to check out and register for some of the webinars that you can see on that page. And lastly, at the end of the webinar today, we're going to switch into a feedback mode, and we'd love to get some feedback from you about what we've done today, what we've done well, what we could improve upon, and get a score from you from 1 to 5, with 5 being the best, just to let us know how we've done with today's session. Okay, so that's the housekeeping. Let's get on with the content for today. And as I've said, this is a Journey Through the Cloud series webinar. So in the Journey Through the Cloud, we're looking at common use cases and adoption models for the AWS cloud, hopefully enabling you to learn from the journeys taken by other AWS customers. We have over 1 million customers that have used AWS in the last 30 days. So there's a lot of collected knowledge there that you can learn from, and intend to share some of that back to you through the course of the session today. And we're going to talk about best practices that you can use to bootstrap your projects and improve the chances of success for projects that you might be running with AWS or for workloads or applications that you might be deploying onto the AWS cloud. And as we've said, we're focusing on scalable web applications today. Now, this is a super popular use case for AWS services, and there's a very good reason for that, which is obviously that web applications tend to have either growing, variable, or cyclical demand. And those kind of applications fit the cloud generally, and the AWS cloud specifically, extremely well. You can exercise elasticity and automation to real advantage. And the services that AWS can provide allow you to accelerate application development and deployment and get your application, your website application, to market more quickly. And once you've done that, iterate on it more quickly so that you can add new features that your customers may be demanding from you. And there's a really good synergy, a really good fit between the services that AWS provides and web applications for those 4 reasons. What are we going to cover in today's session? Well, we're going to talk about why customers choose to use AWS for this type of workload, for this kind of application, for their scalable web applications. We'll take you through a pretty detailed rule book of principles that you can apply when you're developing, deploying, and operating web applications on AWS. And then we'll talk about common patterns. And we'll then show you, as usual, some resources that you can use to learn more about applying the AWS cloud to this particular type of use case. So let's get started with why you might choose AWS to deploy your web applications. And the first thing to say, of course, is that you're not alone in making the decision to deploy applications of this type into the AWS cloud. We have some really very well-known and very large customers that are running their web applications on the AWS cloud. For example, Lamborghini, they've been able to support a 250% increase in their website traffic following a new product launch after they migrated their website onto the AWS platform. Unilever, they migrated over 500 web properties to AWS in less than 5 months, which gave them a standardized digital marketing platform running on AWS and capable of supporting multiple campaigns around the globe for them, as well as reducing the time that it took them to launch new projects by 75%. Airbnb, their usage is summed up in a really simple quote from one of their engineering team, Toby Knupp, who says, "Because of AWS, there's always been an easy answer in terms of time required and cost to scale our site." And then lastly, a reference that we're going to talk about in more detail, Reddit. Now, this is a social news site, as many of you will know. Really very large scale in terms of the amount of traffic that they generate, servicing over 4 billion page views per month. And their total organization only has 20 employees. So it's an extremely lean company with actually not a lot of resources, but a very large amount of traffic. And what happened after they launched was, and they did their initial launch on physical servers, they found that their traffic was growing really quickly. They faced 400% growth, so 4 times the number of users just inside an 18-month period. And they realized there that they couldn't really scale the business, scale the traffic levels in the way they wanted to and needed to with a traditional on-premises, their owned environment. So they migrated to AWS, and that's enabled them to deal with this phenomenal level of scale that they support, those 4 billion page views per month, running their website with only 20 employees. And you can find out more about Reddit and actually many of those other case studies that we talked about a second ago if you visit awsamazon.com/solutions/case studies. You'll find those references and many others detailed there. So why AWS for web applications? Well, firstly, you can pick your platform, whether that's Windows or Linux or a variety of other x86 operating systems. And you can pick your software platform that runs on top of that as well, whether it's .NET, Python Flask, PHP, Ruby on Rails, whatever you want to build in. You've got the flexibility to use your favorite tools on the AWS platform to support your web application. You can grow and shrink capacity to match demand, and we'll show you more about that in a few minutes. You can defocus your investment and your time on the undifferentiated heavy lifting of operating your platform. Focus that time and money on things that really add value to your customers, maybe enhancing your application, maybe marketing your application to new markets or new customers. And that might lead you to need to take your application or site global, or at least expand into new territories rapidly. And again, it's something that's very easy to do with the AWS cloud. And you can have the capacity that you need to make sure that your customers never have to wait for access to your application or site. So the 6 things there that are really good reasons that might make you choose AWS to run your web application on. Once you've done that, what are the rules that you should follow in order to make sure that your web application will scale effectively and efficiently on the AWS platform? And there's 6 different components that we're going to look at here in turn. Starting with the requirement that you have to service all the requests that come to your website. And obviously, the first thing that customers are going to need to do in order to access your application and subsequently data is to resolve the host name of your website to the specific address or addresses where it's located on the internet. And for that to happen, there needs to be a DNS request which will connect your users with your application by doing that resolution for them. It's pretty obvious that if there's any issue with DNS, if that's not working for some reason, and you've got a fundamental problem with customers having access to your site and to your application, it's irrelevant really whether or not your application's available if customers can't resolve you, if clients can't resolve you. And AWS have a service called Route 53, which is a managed DNS service that can help you deal with the challenge of deploying and scaling DNS. It has some advanced features as well as a very fundamental feature, which is 100% availability SLA commitment from AWS to you with a set of service credits that sit behind that. You can find out more about that at awsamazon.com/route53/SLA. This service is global, so it's delivered from AWS global edge locations around the world, and it's scalable, so it scales elastically on the basis of query volume, so you'll never have to worry about how you deploy or scale your DNS infrastructure. Supports advanced services like latency-based routing, which we'll talk about in more detail in a moment, as well as integration with other AWS services like Route 53, integration with Elastic Load Balancers, with S3 and with EC2. So it's very simple to configure DNS records that point towards other AWS services and will scale very easily once they've been configured. And lastly, we have integration with our Identity and Access Management Service, IAM, which gives fine-grained control over DNS record access. So you can have specific IAM roles, specific IAM users within your account that have access only to a subset of your DNS records, for example. So you can control who can do what, and of course, audit that with AWS services like CloudTrail. So once you've got your reliable DNS service in place using Amazon Route 53, and you can resolve queries, DNS queries, and route those onto your application, how do you make sure that your application is available behind that? Well, the first trick is to use multiple regions with load balancers in each region. This can enable you to distribute traffic across several copies of your website, located optimally to ensure that customers get the best possible performance. And you can see an example of this architecture shown on this slide here with 2 ELBs, elastic load balancers, distributing traffic across 2 availability zones in each region where they operate, and making use of this multi-region capability to service customers around the world as rapidly and effectively as possible. And of course, behind your application, you're going to have data sources that you need to access. These again are services that are delivered within availability zones within regions, or on a regional basis in the case of a service like Amazon DynamoDB. We'll cover these services in more detail later, but this can enable you to make sure that data is located locally for each copy of your website that you're running, and that users have a good and consistent performance. And obviously, tricks and tips that you might need to take advantage of in order to make sure that data is replicated across regions. And again, we'll cover that in a little bit more detail later in the session today. So how about servicing requests as quickly as possible? If you've got a couple of regions that are hosting your customers, your website rather, for your customers, how do you go about choosing the closest endpoint in order to make sure that customers have the best and most reliable and effective user experience when they're using your application or website? And the answer to that is a service called latency-based routing, which we touched upon a second ago. So this is a feature of Amazon's Route 53 DNS service. And this works by the Route 53 DNS resolver that your customers made a request of, being aware of the relative time that it will take that customer to reach the endpoints that are available across a couple of regions. And you can see here that Route 53 is regularly making queries to those endpoints and establishing the latency that's going to apply to them. And it's observing here that region A returns latency of 16 milliseconds and region B returns latency of 92 milliseconds. So when that request comes in, there's a quick check made, and the region A DNS entry is returned back to that requester, because that's the endpoint which is going to offer that customer the most consistent and best performance to access to your website or application. And that's how the LBR function of Amazon's Route 53 DNS service works. Now, the second thing that you can do here is to think about using a content distribution network, a content delivery service, to make sure that you're offloading traffic from your application servers, maybe servers that might previously have held static web content, and delivering that to customers as quickly as possible. And we have a service for this called Amazon CloudFront. Once again, it integrates with other Amazon Web Services products, and it enables you to distribute content to end users with low latency, high data transfer speeds, and it has no minimum usage commitment either. And what this service will do is cache and deliver content locally to end users rather than always reverting back to origin to fetch a piece of content. It integrates with services like S3, so you might, for example, place your static content inside S3 rather than putting it onto your EC2 instances, onto your web servers or application servers at all, and have CloudFront cache that, and then also use CloudFront to cache origins that originate behind your ELB that might be on web or application servers. And customers that want to access those content items will be served them locally from the cache with much reduced latency and much improved performance. Okay, so that's a technique that you can use for offloading your application servers. And of course, the side effect of this, of course, is that without it, your EC2 instances that are running your web and application servers, well, they're loaded with requests for user content. But if you implement Amazon's CloudFront service, a significant proportion of the load from those requests will be handled by CloudFront. So you can use that to scale down your compute cluster, and that can help you with cost optimization, reducing the amount that it costs to serve users with your application or website each month. And it's not just for static content. It also offers a benefit, both a response time and server load reduction benefit for dynamic content. This is by virtue of the fact that CloudFront communicates with the origin using an optimized TCP protocol. So for example, it will keep open a single TCP session to the origin and use that to batch and stream multiple requests to that origin, which removes the traditional overhead associated with TCP session setup and teardown. And that can be benefit from that can be increased even further if you're using encrypted session protocols like HTTPS, where the cryptographic setup time is also offloaded to CloudFront. It takes place over a low latency connection. Then a single connection is held open back to the origin, back to the source, either on S3 or on an EC2 instance or ELB. And you'll find that performance is improved even for dynamic content as a result of those characteristics. So that's one trick that you can use to ensure that you service requests as fast as possible by offloading your application service. Thirdly, caching. So it's possible to offload queries within your data architecture. So we have a service called Amazon Elasticache. It's a web service that makes it very easy to deploy, operate, and scale an in-memory caching tier within your application. And you would typically use this to allow you to retrieve information from an in-memory cache rather than relying on a slower disk-based database, such as a relational database that might be running on Amazon's RDS service, say MySQL or an Oracle database. Rather than necessarily always resorting to queries against that database, you can use an in-memory engine to check whether you've previously made and cached the results from a query, and those might be available to you more quickly from that caching tier than they would be from the origin. We currently support 2 in-memory open source caching engines, Memcached and Redis, and you can insert these into your architecture with just a few small changes to your code. Actually, it's been written up for many different languages. The changes that are necessary are provided to you. And you can use this as a technique for accelerating the performance of the data tier within your application. And that can shave precious milliseconds off the response time for customer queries that might be required to support dynamic page build within your application. So take a look at Elasticache if you're interested in introducing an in-memory caching tier into your application in order to deliver those benefits. Fourthly, and kind of similar really, with the databases themselves, say relational databases that you might be running, unfortunately you've got a characteristic where performance of relational databases tends to degrade with scale. And filling that gap, unfortunately, requires quite a lot of effort. Things like database sharding, where you might want to reduce, minimize, or restrict the amount of traffic that goes to an individual relational database engine. You may shard your database to do this. For example, putting all customers in that have usernames ending with an A, B, or C in one database, D, E, and F in another database, and continuing throughout the whole alphabet. Now, this can be complex in terms of cluster management and fault management. You may also introduce other techniques like data caching, we've talked about already, or provisioning techniques to allow you to elastically scale your relational database. But there's a lot of complexity in that. We've got a service that can make that a little bit simpler for you, a service which offers good and consistent database query performance. It's a service called Amazon DynamoDB. And query performance with DynamoDB does not degrade in the same way that query performance degrades in relational databases as they get larger. We've done the heavy lifting behind the scenes to create a fast and flexible NoSQL non-relational database service that offers consistent single millisecond latency at any scale. It's fully managed and it supports both document and key value stored data models. And you can find out more information about it at AWS Amazon.com/DynamoDB. It's table storage in the cloud essentially with a flexible schema that allows you to store documents or store key value pairs in a very scalable infrastructure where you just dial in the amount of database performance that you need, and Amazon Web Services takes care of provisioning the infrastructure and resharding your database in order to deliver that performance for you. If you want to learn more about a customer that's using this for a very, very demanding use case, I'd advise you to take a look at this case study from AdRoll. This takes the form of a video that you can access on the AWS website, and it talks about the way in which AdRoll are using DynamoDB to support their ad retargeting platform. Moving on from how you deal with requests with speed, we're going to take a look at scaling now, how you might scale up your architecture or scale out your architecture to enable you to handle requests at any volume and scale. And the first thing to say here is that with EC2, the Elastic Compute Cloud, you have a broad range of different CPU, memory, and local storage options that you can take advantage of. As you may know, there are 7 different families of EC2 instance available to you, from the T2, which is the T2 Micro, the T2 Medium instance family, through to the C3 and C4 compute optimized instances, the R3 memory optimized instance family, and the I2 and D2 IO and storage density optimized instance family. So you can essentially stop and start your instances in just a couple of minutes, and when you start them, you can start them up on new hardware that might be larger or smaller, or just with a different mix of resources. So you may, for example, go from an M3, a balanced instance type, over onto an R3 if you identify that your application is memory constrained, RAM constrained, giving you best possible cost per gigabyte of memory and unlocking more RAM for your application to make use of. But of course, with anything that scales up, there's always a limit, and there's always a finite amount of capacity that you can have within one EC2 instance, even if that is very large, with 60 gigabytes of memory and 36 CPU cores in our largest instances. You're always going to hit a limit eventually, and for that reason we recommend that customers that are dealing with extreme scalability create their applications in a way that enables them to take advantage of scale out scaling rather than the scale up. And to do this simply with Amazon EC2, we have an adjacent service, an associated service called auto-scaling. And EC2 auto-scaling allows you to scale your EC2 capacity up or down automatically according to conditions that you define. So for example, you might increase the number of EC2 instances that you have to deal with periods of heavy demand and decrease it when demand falls away again in order to reduce your costs, which is the familiar auto-scaling. What some people don't know is there are actually several ways that you can drive auto-scaling. The most commonly known is by policy, where you might scale in response to changing conditions based on user configured monitoring and alerts. But you can also do this manually with an API call. You can do it by schedule, where you add or remove instances at a certain time of day or on a certain day of the week. And you can also automatically rebalance. This will take care of automatically relaunching or terminating instances to make sure that your application is balanced across multiple availability zones, or AZs. We'll take a look at real-world examples of each of these just now. So manual scaling, a good example of this will be preemptive manual scaling of capacity. Say, for example, you're about to do something that you think is going to drive significant incremental traffic to your website or application. Well, why don't you just add more instances before you do that? For example, adding 10 more instances before a mail shot or a real-world marketing event that you might be running, maybe a TV ad campaign, to help you deal with the additional traffic that's going to drive. Speaking of TV, you might also do something on a schedule. So we've got one customer, for example, who adds additional capacity at certain times of the week, just in advance of them broadcasting a television show which has an associated website which drives a lot of traffic for them. You can also do this for things like batch processing in the cloud, where you might put all of your batch jobs into a queue, a simple queuing service queue, and then create worker instances at night in order to deplete the messages in that queue and handle those tasks. By policy would be the classic auto-scaling on metrics. So you're scaling in response to queue depth, CPU load, or load balancer latency, and you're going to add additional instances to help reduce that average level of load across your fleet of instances. And that will obviously ensure that your users get good and consistent performance from your application or website. And then lastly, auto rebalancing. So this is commonly used in failure scenarios. Say, for example, one availability zone becomes unavailable. This auto rebalance can be used to repopulate the remaining availability zones with the instances that are no longer accessible, and obviously reverse that process when that of AZ becomes available again. There are also several AWS services that allow you to dial in specific levels of throughput. A couple of examples are EBS, the Elastic Block Store. These are persistent block devices, storage devices that you can attach to EC2 instances. They come in 3 different flavors. The magnetic volumes, which use traditional rotational drives and have a maximum capacity of 1 terabyte. And then 2 flavors with a maximum volume capacity of 16 terabytes. General purpose SSD, which has 3000 IOPS per volume up to 1 terabyte. And a maximum of 10,000 on a volume up to 16 terabytes in size. And then the other derivative, the provisioned IOPS volume, which allows you to dial in a specific level of I/O throughput or IOPS that the volume is going to support, up to 20,000 per provisioned IOPS volume. And these are good for predictable performance for demanding workloads such as databases. And you can dial the IOPS up on demand using the API console or command line interface. So if you do have an application which is driving more I/O, then you can switch it to a PIOPS volume and drive the IOPS up using that dial, give you more performance. Similarly, with DynamoDB, you can specify provisioned read-write performance per table, once again scaling this via the console API or command line tools. So as your database gets to be used more intensively, you can increase the level of performance that it can support by dialing up read-write performance. There's also a third-party tool for auto-scaling with DynamoDB, which is called Dynamic DynamoDB. This was contributed by an AWS user based in the Nordic region. And if you want to know more about Dynamic DynamoDB, then check out that URL that you can see bottom right on this slide. That'll provide you with some further information about that. Something that we hear from a lot of customers is that there's a lot of benefit from simplifying your architecture using AWS services. And I really like this quotation actually from this French writer from the early part of the 20th century who said, "Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away." Probably didn't think about IT architecture when he conceived and wrote that quote, but it's one of the most relevant quotes as far as I'm concerned when considering how to improve the architecture for an IT service or application. If you take stuff away, there's much less for you to worry about and much less to go wrong as well. And you can do this with AWS by allowing AWS to support you by providing managed services for non-core components of your application. It's probably contra to this with infrastructure that you own and operate. You spend a lot of time, actually up to 70% of your time, doing things that don't really differentiate you. It's installing servers, it's configuring and installing software, it's managing data protection, it's dealing with scaling and reliability issues, which really don't add that much to your application or to your customer's experience. You can contrast that with AWS-based cloud infrastructure. You've just got that much more time to focus on what's important because it takes you that much less time to simply configure services than it does to deal with planning, deploying and operating them. And there's several different services that are good examples of this, some of which we've already talked about, things like RDS, the relational database service, or DynamoDB, our provisioned throughput NoSQL database. They can help you manage persistent data storage for your application with the right sort of application characteristics, performance, data protection and scalability characteristics built in from day one, which you just don't have to worry about or spend your time on. Just dial in however many PIOPS you need on your RDS instance, specify whether or not you want multi-AZ for data protection, and you're good to go. And the same with DynamoDB. Just dial in however many IOPS you want, and you're ready to go with the API or command line based tools for access. And there are other things as well that we haven't covered earlier in the session today. Things like SQS, the simple queuing service. It's a reliable, highly scalable message queuing service that you can use to build a loosely coupled architecture on AWS. For example, decoupling a worker tier or managing batch processing asynchronously by putting batch activities into a queue. And again, you just don't need to worry about deploying or scaling that. Through to more advanced services like Elastic MapReduce, which gives you a framework for managing and operating Hadoop-based workloads on the AWS platform, support for many, many different Hadoop ecosystem tools, integration with other AWS services like S3 and Dynamo, and integration with things like the AWS spot market for EC2. So you can process large volumes of data cost effectively with that tool without ever having to worry about planning or deploying a Hadoop cluster of your own. We see many customers move forward and reduce the amount they do when they take advantage of these services. And of course, there's lots and lots of other AWS services that we haven't covered during this session today. You can see a full taxonomy layout of AWS services on this slide. And you'll see there's other things in analytics, app services, deployment and operations, and mobile services, as well as administration and security, that can simply reduce the amount that you need to do and allow you to focus more of your effort where it's important on functionality and scalability within your application rather than on the infrastructure. And one of the ways you can do that, of course, is by looking at automating operations and management. One of the most important characteristics of the AWS cloud is that everything is programmable. We currently have 9 SDKs that are fully supported, and another one that's currently in development for the Go programming language. And these allow developers to do a couple of things. Firstly, you can directly access AWS services from within your applications. So a simplistic example of that might be, take WordPress for example. Normally you'd store the images and other fixed content assets, static content assets for WordPress on the file system of the application server that runs your WordPress environment. There's a plugin for WordPress which uses the PHP SDK to move static content assets that are used by your WordPress blog or application out into Amazon S3 for storage and integrates their distribution with Amazon CloudFront. So a very simple use case for the AWS PHP SDK that allows the WordPress application framework to communicate directly with AWS services, in this case S3 and CloudFront, to enhance functionality of WordPress. And of course you can build your own applications that do that, whether that's a mobile application that might write images directly into S3, or whether it's a Python-based application for real-time stream processing that might be connected to Amazon Kinesis, one of our tools for managing big data in the AWS cloud. Both examples of ways in which you can put the SDK to work for you directly within your apps. The second thing you can do with these SDKs, of course, is you can programmatically control deployment of AWS infrastructure and resources. So a former colleague of mine wrote a deployment framework for a virtual SAN product. He built that in Python so that he could very quickly and simply spin up lab environments for this virtual SAN, creating a cluster of EC2 instances, putting specific images on them, and performing bootstrapping actions, all from within the Python script, the Python application that he'd written to provide that automation framework. So there's a lot of stuff you can do with the SDKs. If you want to learn more about this, check out the link at the bottom of this slide, awsamazon.com/developers/getting-started, and you can find out more about Amazon Web Services, SDKs, and other developer tools there. Another important tool that customers use, process that customers use, actually I should probably say, is to move towards this idea of immutable one-click deployments, where AWS resources are deployed in concert, in conjunction with an application deployment. A couple of examples of tools that you can use for this. One is AWS CloudFormation. It's an easy way to create and manage a collection of related AWS resources, which we call a stack. And once you've defined your stack in the AWS CloudFormation templating language and saved that in a JSON file, you can use that to automate creation of stacks in a repeatable way. And this allows you to version control your infrastructure as you do your software. It's used extensively by many AWS customers. For example, here in the UK, Just Eat, this is the restaurant and takeaway service. They define their application components using AWS CloudFormation templates that are generated programmatically by their CI/CD framework. When they do a new build, a new deployment, they create a new set of resources, pull down specific application deployment bundles, deploy those onto those instances, and then cut over API endpoints to put that new component of their application live. And that's all wrapped up in their CI/CD deployment toolchain. So it's a good example of a customer using CloudFormation to support continuous delivery. So that's one example of a tool that you can use for immutable one-click deployments. And then something a little bit newer is the Amazon EC2 Container Service. So this allows you to launch and terminate applications that are running inside Docker containers across a cluster of EC2 instances. It has sophisticated features like making it possible to mount persistent volumes at launch and make use of private Docker repositories that you might populate with Docker images, once again from your CI/CD toolchain. And you can use this to integrate your deployment into, obviously, with packaging in the form of Docker containers, and to stack your workloads inside those containers onto a cluster of EC2 instances in the most optimal way, using either our scheduler or a scheduler that you define yourself. And that, again, is another way to achieve this goal of having an immutable one-click deployment framework. You can find out more about that at awsamazon.com/ECS. Of course, this idea of automating operations and management doesn't just extend to the point at which you're deploying your app, although if you are doing that, you may want to use techniques like bootstrapping to enable you to customize instant startup, but also to auto-scaling to enable you to maintain capacity of instances, to add and remove capacity dynamically, as we've mentioned, for ensuring good user experience and also optimizing your costs. And then using tools like Amazon CloudWatch, which allows you to create standard and custom metrics from your AWS environment, use those to trigger alarms and respond with automated administration actions to those alarms. To add further intelligence to your environment, because you know what's going on, you can take automated actions in response to that, of course. As well as our own tooling, a few of which we've described there, there's also extensive third-party tools. One of the best known is this project. It started out as the Chaos Monkey, and then it mutated into the Simian Army. And this is a Netflix OSS project, which lives on GitHub at the URL that you can see there. And this will not just simulate, it will create failures inside your AWS environment to ensure that you've used good design for availability principles inside your architecture, and that if you do have real failures in your environment, those aren't going to impact the service that you provide to customers. And there are many other third-party tools that offer this and similar functionality and other functionality that can help you further automate operations and management of your AWS environment. Lastly, using the unique properties of the cloud to optimize your costs. This is something that it's quite difficult to do with infrastructure that you might own and operate either on your own premises or in a co-location facility. But as I've mentioned earlier, it's very simple for you to change the EC2 instances that you're using, and a process that we'd recommend all customers go through at the time at which they first deploy their application or website onto AWS is to start with an instance that best meets their basic requirements. So we're starting with memory here and choosing the closest number of virtual cores that are available. And then we're going to tune this on the basis of maybe an early release, maybe a beta, maybe some load generated by a load testing tool. And through this tuning process, we're going to tune our instance size up or down on the basis of that monitoring. And then we're going to deploy and scale at that point once we're happy that we've got the instance type that gives us the right resources that we need to run our application or website in the most optimal way. So if you go through that process, that will help you ensure that you're optimizing your costs at day one. Another optimization technique that you can use is to use the reserved instance purchasing model. So this is where you pre-buy EC2 capacity in advance of you needing it, either for a 1 or 3 year period. And by doing this, you can achieve some spectacular levels of discount. For example, saving up to 75% with certain purchasing models if you're prepared to make a commitment for some of your capacity over a longer period of time, rather than simply paying by the hour as you can consume it. And you can see here in this representative workload profile that you can blend those two things together. Here, the capacity that we're using for more than 50% of the day, we've purchased as reserved instances in order to minimize our costs. And then with the rest of our capacity, we allow to be consumed on demand, because that's the most cost optimal way for us to source the capacity that we need for less than 40% of the day. Those numbers may vary. Take a look at the EC2 product detail page for more information on reserved instances and discounting. But you've got a really good optimization opportunity there if you have a typical cyclical web-based workload where you've got more utilization at certain times of the day than at others. So that concludes our rule book. Let's take a very quick look because we're running out of time, let's take a very quick look at common patterns for web applications. So 4 things that we see customers move towards as they become more mature in their usage of the AWS cloud. Well, firstly, increasingly we see customers move towards having a stateless, horizontally scalable architecture for their applications. So minimal amount of stateful footprint on your web or application servers, using auto-scaling together with pre-baked Amazon Machine Images or armies to enable you to dynamically scale the size of your fleet, and then having loose coupling with services like SQS, the simple queuing service, to allow interchange of messages between different tiers of the application. And this allows you to, for example, scale your web application and worker tiers independently of one another while still reliably delivering messages between them and ensuring that your application functions in the way that your users expect it to. And couple that with automation as the fourth corner of that square of patterns, and that's what we would consider a good application architecture for running high-scale web applications on the AWS platform. So we're going to close up by talking about resources that you can use to learn more. By the way, if you do have questions that you want to ask as a result of what you've seen in today's webinar, now would be a really good time to submit those via the Q&A panel that you can see in the webinar interface. I'll try and answer as many of those as I can at the end of today's session in a few minutes. Those that we don't get to, we'll come back to over the course of the next few days in email from our solutions architecture team. So submit as many questions as you want. You'll definitely get an answer. We'll answer as many as we can today. Others we'll come back to after this session. So the first important resource for you is this one, awsamazon.com/websites. Here you can find a collection actually of many of the other resources that I'm going to talk about, as well as links to relevant product detail pages and documentation on the AWS documentation website that will guide you through these best practices for running high scalability websites and web applications on the AWS platform. So do check that out, awsamazon.com/websites. We touched upon case studies earlier, but I'd love you to go and read up a little bit more about how some of these high profile customers use AWS for this particular use case today. You can find the case studies that we've touched upon during this session, including AdRoll, Reddit, Unilever, Airbnb, Lamborghini, a lot of others, at awsamazon.com/solutions/case studies. And another really important resource in the AWS website is this one, the Architecture Center, awsamazon.com/architecture. This contains architectural blueprints that you can use for deploying commonly deployed applications onto AWS using patterns and best practice for architecture. Check out this one for web application hosting, which summarizes many of the things that we've talked about during this session in a simple to review asset from our Architecture Center. And there are around about 40 other application patterns that are also addressed with architectural blueprints at the same place on the AWS website. So really useful resource if you consider yourself interested in systems architecture. Of course, if you want to develop that further beyond the content that we're delivering in our webinar series, you may want to take a look at AWS Training and Certification. We have self-paced labs, we have classroom-based training, and we have a certification program that enables you to validate your AWS skills and expertise. Check those out. AWS Training has links to the other two at awsamazon.com/training. And lastly, if you want to stay up to date with AWS, please follow us at the social media accounts that you can see on your screen here. If you're interested in keeping up with me, I'm at E&M with 4 M's. You find us at AWS_UKI here in the UK and Ireland, where you can keep up to date with local AWS events and news. And you can stay up to date with AWS globally at AWS Cloud. We're going to take a few questions in a second, but before we do that, I'd just like to thank you for giving us your time to join this session today. We do appreciate you spending your time to learn a little bit more about AWS. I hope it's been useful for you. We're going to put the webinar interface into Q&A mode now, which will also reveal the ratings panel. So please give us a rating for this webinar from 1 to 5, with 5 being the best. And please do leave us any further feedback you've got via the Q&A panel as well. You can do that as well as submitting questions. We'd love to have your feedback on things we could improve for next year so that we can give a better experience for customers if we deliver this session next year. And thanks again for joining us. Let's turn to and take a few questions now. Thank you.